All right, guys, today we're going to do integration with logs. Let's pull up the notes. Okay. All right, let's see. This is integration with logs. If you logs, you remember when we take the derivative of log, we get 1 over x. So it makes sense that if we integrate 1 over x, we get the natural log of x. And this is the formula you see most often because it works for more than just when there's an x here. 1 over u du is the natural log of u. So actually, before I jump into this, what I really like to do is show you several examples and see kind of if you can notice the pattern. Okay, so let's see. Okay, so again, when we take the derivative of the natural log, now remember, the derivative of the natural log of something was the derivative of u over u. So if I had like the natural log of x plus 2, it would be the derivative of x plus 2, which is 1 over x plus 2. If I had the natural log of x squared plus 2x, the derivative of this would be 2x plus 2 over x squared plus 2x. So basically, you take the derivative of this stuff, put it over the stuff. So now we're trying to go backwards. So if you see a function where you see some function and you see its derivative or some multiple of its derivative on top, then you know that it's natural log. And notice this group right here is not raised to any power. If it's raised to a power, then that would be a different rule. That's like reverse chain rule or u substitution. So I'm going to go through, I'm going to write out the answers. I'm going to pause and I'm going to see if you can figure out the pattern. Okay. Let's stare at these for just a minute and see if I can figure it out. What's going on? Okay, what do you notice? I want you to look at the denominator in each of these. Where does the denominator appear in the answer? Hopefully you're seeing that that denominator is the natural, it's in the argument of the natural log, right? So because remember, it's the derivative over the stuff. As we're going backwards, we take the derivative of this and put it over itself. Now, I have a coefficient in front of a lot of these, not in front of all of them, but let's look at that coefficient and see if you can figure out where that came from. So I have a 1/3 here. Whoops, let me change the color. So 1/3 here, 1/4 here, 2/7 here, 1/2 here. How does that work here? Let's see if you can figure out what we're doing. So what is, this is your u essentially. I'm doing u substitution, but just as in my head essentially. And I'm trying to see if you guys can see the pattern as well. And then I will write it out the long way too. This is your u. So your du then would be 3 dx. You divide this by that derivative. So that's where this 1/3 is. What's the derivative of this? 4. So we divide the 1 by 4. That's where this 1/4 comes from. What's the derivative of this guy? 7. So we divide this 2 by 7. That's where that comes from. What's the derivative of this bottom? 2x. So we're dividing x by 2x and we get the 1/2. It works as long as the derivative cancels, okay? So as long as this power is 1 more than that power, it will work out, or most of the time. You have to make sure it cancels. So what's the derivative here? The derivative of this guy is 3x squared. So if I divide x squared by 3x squared, I get 1/3, which is this coefficient right here. What's the derivative of this? 2x plus 2. So I just have my derivative right here. So it is essentially seeing that you have du over u. Anytime you have du over u, the answer is the natural log of u, because it's the reverse of the logarithm derivative rule. Okay, so hopefully that makes a little bit of sense. But now I'm going to go ahead and, or here, let's do a couple more examples before I go back to those notes. Okay, so what if I had, again, I look at this and I see what is the difference, even if I have something like this. Okay, what's the derivative of this? 4x plus 5. The derivative is 4, so the coefficient is going to be this divided by 4, and then it's the natural log of the bottom. What's the derivative of this? X squared goes to 2x, so 5x over 2x would be 5/2 ln x squared minus 7. The derivative of cosine is negative sine, so you're going to have negative natural log cosine x plus 1. Okay, let's go to the notes now, and I will show you more officially how to do it. But if you got the pattern recognition down, you're good. So maybe you can just look at this now and tell me what the answer is. But if you cannot, we can write out u just like we did before. We can say u is 2 minus 5x. And then the derivative of u here is negative 5 dx. Divide by the negative 5. So then when I go to write this, I have 1 over u, and instead of writing dx, I'm going to write du divided by negative 5. So that's like negative 1/5 out front, negative 1/5, 1 over u. And 1 over u right here goes to the natural log of u. So negative 1/5 ln of u plus c, so that'd be negative 1/5 ln of u, which is 2 minus 5x plus c. Or you can just look here and notice the derivative of this is negative 5. 1 divided by negative 5, that's where this negative 1/5 is. Natural log of the bottom. This one, u is x cubed plus 4. So the derivative of u would be 3x squared dx divided by 3x squared. So I have x squared over u, and instead of writing dx, I write du divided by 3x squared. So these x squareds cancel, and so you get the 1/3. And then the integral of 1 over u du is natural log of u, and u is x cubed plus 4. So that's how you write it out with the u substitution. Same idea here. For this one, the u is the bottom in parentheses, so u is 1 plus x to the 1/3. The derivative of that is 1/3 x to the negative 1/3, which is 1 over 3x to the 1/3. So multiply by that. Wait, negative 2/3. Sorry, I subtract 1. I need to subtract 1. So 3x to the 2/3 equals dx. So if I write this, I have 1 over x to the 2/3 u, and instead of dx, I have 3x to the 2/3 du. X to the 2/3 cancel. So you have 3, 1 over u, so it's 3 natural log of 1 plus x to the 1/3. This one is a little bit different, and because you notice it's not this pattern where you have the derivative of whatever on the bottom is the top. So in this case, you're going to pick this to be your u, the thing inside the parentheses. And the derivative of natural log is 1 over x dx. So I have u to the fourth over x, and then dx is, if I solve for dx, I get x du. So these x's just cancel because that is there because it's the derivative of the natural log. So you're trying to reverse the chain rule. So it's going to divide away when you go backwards. So then you just increase the power by 1. So the answer is the natural log of x to the fifth over 5 plus c. Because if I took the derivative of this, the 5 would pull down, the 5s would cancel, and then you have natural log of x to the fourth times 1 over x. And so we're going the exact opposite of that. So you're dividing by the derivative, that goes away, and then increasing the power by 1 and dividing by that new power. Same idea here, except, so in this case, your u is actually the top. Okay, it's to the first power, but your u is the natural log of 4x. Your du would be 4 over 4x, or just 1 over x. And then solve for dx. So I have u over x, and then dx is x du. So those x's cancel. So you're just integrating u. And so the answer is u squared over 2. So natural log of 4x squared over 2 plus c. So it's actually just like the one we just did, except instead of to the fourth power, it's just to the 1 power. And then you have that 4x there, but that canceled out anyways. Okay, now this is another concept that we need to know. If you look at this problem, you notice that the derivative, notice that the power on top and the power on bottom are the same. So it's not going to cancel out. Usually it was 1 less. Same here. This one actually is 1. This is a couple more than that one. So if you have a power on top that is the same or greater, you have to do long division first before you integrate. So we're going to do long division. Like, just a recap of long division. If I was going to say this was what I was dividing. 5 into 352. I would say 5 times what is 3? Well, nothing. 5 times what is 35? 7. 5 times 7 is 35. Switch the sign, subtract, and bring this one down. 5 times nothing goes into, so I can't do this anymore. So my answer is, I would say 0, right? And then I could say 70 and 2/5, right? So let's figure out how we would do that here. Recap of long division. I have 4x squared minus 5x minus 12. I have x squared minus 3. X squared times what is 4x squared? 4. So I'm going to multiply both of these times the 4. X squared times 4 is 4x squared. Negative 3 times 4 is negative 12. And then you have to change both signs. So change that and change that because you're subtracting the quantity. So flip both signs and then bring down whatever is left. I'm done once this power won't go in. Like, x squared is a bigger power than x, so I'm done. So the way I write my answers, I write 4, and then I take whatever this guy is, the remainder, and I put it over the divisor. And I'm going to integrate this quantity, which is the same as integrating 4, and then the integral of 5x over x squared minus 3. The integral of 4 is 4x, and this integral, I am going to do my logarithm. Derivative of x squared is 2x, so I'm going to have 5/2 natural log of x squared minus 3 plus c. So let's try the next one. If I integrate this one, I need to divide first. X times what is x cubed? X squared. X times x squared is x cubed. 5 times x squared is 5x squared. Switch both signs, so negative, negative. So now I have negative 5x squared minus 6x minus 20. X times what is negative 5x squared? Negative 5x. X times negative 5x is negative 5x squared. 5 times negative 5x is negative 25x. Switch both signs. So now I'm left with, what's 25 minus 619. X minus 20. And then X times what is 19X? 19. So 19X and then 5 times 19, what is that? 595. So then I get to switch both sides. So I get negative 115. So at this point, to write my answer, I take this and I write the entire here quotient. So x squared minus 5x plus 19. And then I take the remainder and I put it over the divisor. All right, and then I'm going to integrate this entire thing. And with long division, what happens is all this stuff ends up being normal. By normal, I mean like add 1 to the power, divide by, and then it's ln at the end. That's usually the pattern for this situation. Oops. Okay. X cubed over 3 minus 5x squared over 2 plus 19x minus 115 ln x plus 5 plus c. Okay, let's do, sometimes you have to do something tricky. Let's see, and then there's trig, seeing what we have left. Okay, so notice this one, if you play around for a few minutes and you try to make that u, I'm gonna see you get stuck. So if that happens, when you're trying to do substitution and you have trouble picking u and you're like, what's going on? Okay, let's get back to this one. Okay, this one is quite a tricky problem. But you guys can do it, you can stay with me. All right, so this one, after trial and error, picking several things as u, we found out that it works to make u the square root of x, which is x to the 1/2. So the derivative of u then would be 1/2 x to the negative 1/2 dx. Or another way of looking at that is 1 over 2 root x dx. We solve for dx, we get 2 root x du equals dx. But what's kind of unique about this problem is that the square root of x happens to also be known as u. So we actually get 2u du is equal to dx. So now we're going to rewrite this integral. We have 1 over 1 plus, now instead of writing that, I'm writing u. And then dx, instead of writing dx, we're going to write what it's equal to, which is this, 2u du. Okay, so I have 2u over 1 plus u du. Now I have a situation where I have the same power, 1 and 1. That means I have to do long division. So I take 2u, I divide it by u plus 1. U times what is 2u? 2. And you multiply both of these times 2. So 2u plus 2. Switch the signs. So we get 2 minus, we take the quotient and put it over the divisor. And then we're going to integrate each of these. The integral of 2 is just 2u, and then that is going to be 2 natural log of u plus 1. And then lastly, you put back in what u is. U is root x, so we get 2 root x minus 2 natural log root x plus 1 plus c. That is the answer to that problem. A little bit tricky. All right, since we know natural log, now we can talk about a few of the trig derivatives that we didn't have. If you remember, we only knew these 6 here that were the derivatives of the original trig functions. So we knew, hold on, we gotta read for 15 minutes. Read for 15 minutes first. Okay, so we knew this one, the derivative of sine is cosine, the derivative of negative cosine is sine. We knew the derivative of cotangent is cosecant squared. We knew the ones I starred, okay? Because these guys are the derivatives of the original 6. So we knew the antiderivatives of these happen to be the original 6 trig functions, sine, cosine, tangent, secant, cosecant, cotangent. But what about if I just have tangent or I just have secant? Well, there's a proof for that, which I will show you, but then you can also just memorize it. So if you remember, tangent can be written as sine over cosine. And hey, what do you see? Cosine, what's the cosine's derivative? Negative sine. So we have really, if I use a different, I'll use W instead of U. If I say W is cosine, dW then would be negative sine U, du, divide by negative sine U. So I have sine U, du is dW over negative sine U, so those sine U's cancel over W. So I'm left negative 1 over W, dW. So negative natural log of W plus C, negative natural log of cosine of U plus C. Secant is a little bit more tricky to prove. You pretend like it is over 1, and then you multiply by a very weird term, but it works out. You multiply by secant U plus tangent U on top of itself. So it's a weird form of the number 1. When you do that, you distribute, you get secant squared plus secant U tangent U over secant U plus tangent U. And hey, what do you know? The derivative of secant is secant U tangent U, and the derivative of tangent is secant squared. So we just have a function and we have its derivative on top. So the answer is the natural log of the bottom. So we could prove the other ones for you as well, or like I said, you can just memorize them using this chart here. So how does it actually work? Well, now when I see cotangent, I know the antiderivative of 2 is 2x, or in this case, theta. The antiderivative of cotangent is negative, no, it's positive, it's the same sign. Natural log of sine of the inside plus c. And you always need to check for the u. In this case, u would be theta over 4, so du would be 1/4. And you divide by the derivative. Dividing by 1/4 means we're going to multiply by a 4. This one, I need to say that the bottom is u, so that du would be secant squared. And so I notice that that's just du, and that's u, right? We have du over u. And so the answer is natural log of the bottom, because it's perfectly works out where this happens to be a function and its derivative. So I don't usually rewrite the whole integral when I notice that it's perfect like that. Okay, this one, if I want to take the antiderivative of this, I notice this is 1 degree higher. So it's the natural log. And the shortcut to that I like to do is I just take this and I divide it by the derivative of this, which is 2x. So I get 3, and then it's going to be natural log of the bottom. Normally we put plus c, but we have bounds. This is a definite integral, so that means we're going to plug in the top bound and then subtract when we plug in the bottom bound. So I get 3 natural log of 9 plus 1, so that's 10, minus 3 natural log of 1, natural log of 1 is 0, so we get 3 ln 10. This one is tricky. We're going to make the u actually the natural log of x. The derivative of u is 1 over x dx. So if I solve for dx, I get x du, because you multiply by x. So I get 1 over x u, and then dx is x du. So what happens is we actually are integrating 1 over u, and the u itself is natural log. So we get the natural log of u, but that's the natural log of the natural log of x. From e to e squared. So the natural log of the natural log of e squared minus the natural log of the natural log of e. And these cancel and just give you 2. So ln of 2 minus this just gives you 1. And the natural log of 1 is 0. So this is just the natural log of 2. Okay, hopefully that helped some. And as always, I'm happy to answer questions when you're attempting your homework assignment. Just reach out to me.